Hello everyone and welcome. My name is Eric Coleman with IIST and I'll be the moderator for today's webinar, You Don't Need No Stinking Test Cases by Robin Goldsmith. We're excited you're able to join us today and set aside an hour to attend this webinar. This webinar is sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit testinginstitute.com. This webinar is one of a series of free webinars offered by IIST. Be sure to join us for the next webinar in this series, Testing in a Continuous Delivery Pipeline, Faster, Better, Cheaper, on March 29th from 11 a.m. to 12 p.m. Central Standard Time. To learn more about this and other webinars in the series, go to testinginstitute.com. You may submit your questions at any time by using your question box in your GoToWebinar window. Today's presenter will answer as many questions within the time allowed at the end of today's session. This webinar is being recorded and will be made available for viewing within 48 hours at testinginstitute.com. At the end of today's webinar, you'll be asked to complete a short survey. At IIST, we strive to provide the highest quality educational resources for the public and would appreciate it if you could take a few minutes to complete this short survey. I will now turn the webinar over to today's presenter, Robin Goldsmith. Robin?
So welcome, folks. If you can't hear me, say so. That's a little joke. Sorry about that. So just a quick reminder that I do present a number of courses and seminars and webinars through IIST. We've got two half-day seminars, online seminars coming up in April and May. We've got 4 days of test lead certification boot camp occurring in June in Boston, June in San Diego, July in Minneapolis. And that's 4 courses: managing the test process, a proactive approach, managing test projects, test process measurement and improvement, and estimating and controlling the testing project. And in addition, I have a number, as do a number of my fellow instructors, have a number of recorded seminars that you can also take through the IIST.org website. And they, along with the Test Lead Certification Bootcamp, qualify for various IIST certifications. Okay. So, pack of lies about me. Okay, I've worked directly with people in a consulting and advisory capacity as well as training. Once upon a time had a real job. I think I still have a real job, but a significant part of my consulting practice involves training people. Got a couple of degrees. I've been a member of a couple of IEEE standard working groups. We'll be looking at one of those a little bit later. Been a subject expert for Babok and for TechTarget.com. And I've got a book called Discovering Real Business Requirements for Software Project Success, and a forthcoming book on writing agile user stories and acceptance test requirements. So I suspect that many of you recognize this phrase, "we don't need no stinking badges," and I've kind of borrowed from that for the title of this webinar. And just as a small point of information, the quote, "we don't need no stinking badges," is not actually in the movie. And the movie that this is from is called The Treasure of the Sierra Madre. It's really a classic film. And so the Mexican bandit doesn't say, "we don't need no stinking badges." He says, "No, we don't need badges, and we don't need stinking badges," but it doesn't say we don't need no stinking badges. But let's get into why we're here. And so is getting enough effective test cases an issue for you? If it is, drop a quick yes in the question box. Let's see if we can get some interaction here on that. Okay. Okay. Yes. Sometimes. Okay. Yes. Okay. Great. Thank you much. So here's what I see as objectives for this. We want you to be able to understand the essentials of test cases and some keys to making them effective. In fact, we're going to mention 4 of them. Going to describe some low overhead test case formats. Some of you may not be accustomed to that. And want you to become conscious that there are ways to help you avoid overlooking as many important test cases as you overlook. It's not going to say you don't overlook some. It's not going to say you have time to test them all or execute them all, but you cannot execute a test case that you are not aware of. Okay? So hopefully these objectives are understandable and reasonable for why you're here. Okay? And so we want to create some awareness of what test cases are and are not, and how you can be more efficient with them, and as well be more effective. So test case is testing's basic work unit. Simple question, what is a test case? So if you would you please type into the questions box how you would define a test case? And as you're doing that, I'm going to continue on here, and I will tell you that my view of the answers box is somewhat constrained. So I'm not necessarily going to be able to read everything that you've said, but I can kind of see them flipping by here. And so thank you for those as you're entering those, and we'll try to look at them in more depth in a while. Okay, so let me tell you about an experience that I had. A couple of years ago, I was reading a testing book, and I know that that's, a fate worse than death for a lot of us. But I was reading a testing book by one of the best known people in the industry. It's a well-regarded testing book, well-regarded tester. I think of this person as a colleague. I certainly have the highest regard for them. But I was struck by one thing in the book, and that is that there was a one-page form that the author described, and the form identified information about the test case, the ID and version number and all kinds of stuff like that. And the author said that you should fill out one of these forms for each test case. And I felt that that seemed like a lot of writing. And so I thought, well, maybe this author means something different by test case from what I mean. And in a rare showing of diplomacy, rather than confronting the author, I put together a brief survey listing, 6 or 7 terms related to testing, including test case. And then I sent the survey to about a dozen testing instructors and authors, and including this one who had written this book that I was reacting to. And I got responses back from many of those dozen, and frankly, they all said pretty much the same thing. Everybody pretty much said that a test case consists of inputs and/or conditions and expected results. Some people elaborated a little bit in terms of what results were, like outputs or changes to stored data or changes to the environment or the state. But everybody gave pretty much the same answer. Some people also said things like preconditions and various things about test procedure. But everybody seemed to be agreed that test case consisted of inputs and or conditions and expected results. And so I said to myself, well, if everybody, including that author, is using the same definition for a test case, maybe there's something else involved. Maybe it's not the definition per se, but maybe it's how they interpret that definition. And so I revised my survey, and by the way, you can read about this survey in techtarget.com. Happened to have been picked as the top software quality tip of 2010, the article on it. Okay, so what I did was I put together this example. And I said, look, here is how you could test entering an order for a customer. And I think that you could view this in any of 5 different ways. So where the A in the white arrow is, okay, we could view the whole thing as one big test case. Or where the B's are in the blue arrows, okay, in that case, we would, or in that instance, we would have 7 test cases. Or each place where there's a C in a pink arrow, you might consider each of those test cases. There are 14 of those. Or where there's a D in a yellow arrow, and there are 20 of those test cases, or the E in the light blue, light green, whatever that color is. And there are 24 of those. Now, I know you're saying, well, there aren't that many arrows, but in fact, there's a second page to this. Okay, so I sent out this survey and I said, which is the test case in your opinion? Is it level A, it's all one big test case? Level B, there's 7 test cases. Level C, there are 14 test cases. Level D, there are 20 test cases. Or level E, there are 24 test cases. So what I'd like each of you to do is quickly look at this. I'll show you the second slide again, just to clarify that. Okay. But if you would, type into the question box, is it A, B, C, D, or E? Okay. So I'm seeing number of answers coming in. Okay. And guess what? There's no overwhelming choice. Okay. I'm seeing people picking A, people picking B, people picking C, people picking D, and people picking E. So what's the significance of that? Okay. What's it matter? It matters because any of those answers is a legitimate answer. And it's not that one answer is right and the other answers are wrong. But the problem or the difficulty is whether you and your colleagues are using the same language to mean different things. And there's a very good chance you are. So if somebody is thinking that this is all one big test case, they might say it'll take an hour to run that test case. Somebody else might be thinking at the E level that it's 24 test cases, And they'd say, oh no, it only takes 5 minutes to do a test case. So people can talk at each other using not only the same terms, but the same definition of terms, and still have widely varying interpretations. And so if that's happening, and it probably is happening in your world, then it's really important for you to get clear with your colleagues on a common understanding of what is a test case. And so I encourage my students to use this survey with your colleagues, with your fellow workers. Use it first to get a level setting to tell where people are, and then to use it as a basis for reaching consensus. When everybody is using terms in the same way, then you're going to be at least reducing a major source of confusion. So hopefully you'll find this something you can do and find it helpful. Okay. Now, let's get clear. A test case consists of inputs and or conditions and expected results. And a condition is a form of input, but is often not something that a user might set up. Like a condition might be the time of year, or the weather outside, or you know, what operating system you're using, or whatever. Now, a test case consists of inputs and or conditions and expected results, whether or not they are written down. And if they are written down, there is not any specific format that the test case has to be in. So there are many different formats that a test case might take if it's written down, and it doesn't have to be written down, but it's a test case nonetheless. Now, there are many benefits of writing things down compared to not writing them down. Perhaps you can quickly jot in the question box some of the advantages of writing things down compared to not writing them down. Anybody have any ideas there? I know this will take a little bit longer to type in. Okay, repeatable, I'm seeing. Okay, don't forget. Okay, can follow it to execute, reusable. Okay, don't miss things, knowledge transfer, you can share them, and so forth. So exactly. So writing down helps us prevent from forgetting things. It does help us share things. It helps us repeat and reuse things. We can also review them. We can refine them. We can use it to guide our actions, and we can use the written form to help track what actually happened. Now, each of these is a benefit of writing things down. Of course, those benefits come at a cost. Okay? And so a lot of people think that a test case has to be in some particular format. And it's very common that the format that people think the test case has to be in involves a lot of keystroke-level embedded procedures. Okay, click here, pull this down, turn around, drink your coffee, refill your cup, and scratch your head, and so forth. Now, there are some expected benefits of having keystroke-level detail and procedure embedded within a test case. Okay. The big benefits are that it enables people to more precisely repeat a test and it enables people who have relatively little knowledge and probably are low priced to actually execute those tests. Now, those are understandable reasons or benefits for keystroke-level procedural detail embedded within a test case. But, I would suggest that if precise repetition and execution by anybody is really that important, that test is a very good candidate for automated execution. And an automated test execution tool can repeat that test precisely without getting tired, without making a mistake. Okay? And all things considered, they're probably going to end up cheaper than the cheapest worker that you'd have to hire. And that cost per test or test execution drops dramatically with volume. Now, there are a lot of drawbacks to keystroke-level procedural detail. One of them is that it takes a lot of time of high-priced talent, people like you, okay? Not just to create, but often, more importantly, to maintain those tests as things change. Okay? And the more time that you spend writing down these laborious, detailed tests, the less time you have left for actually executing them. Okay? Ironically, all this effort describing this procedural detail doesn't help in automating, and in fact, it can get in your way. But one of the biggest issues is that you're creating lousy tests, because what you're doing is forcing execution in a manner that would not represent how an actual user would use the system. A user is not going to blindly lockstep say, click here, go there, turn around, sit down, stand up, and so forth. So you're creating a very unnatural situation, and because it's unnatural, it's very unlikely to reveal the types of issues that users would actually encounter. And ironically, the more effort that you spend on being absolutely precise and directive, the fewer errors you're going to reveal with that test. So many of you are familiar with exploratory testing. A lot of people think that it's the best type of testing. Many of you may know Kem Kainer. Kem is the author of the best-selling book on testing. And Kem has since become a professor, and he speaks frequently. And one of the things that he reports in some of his talks is that he did an experiment where he gave experienced testers and inexperienced testers the same test script for each of them to use in carrying out a bunch of tests. And Kem found that the experienced testers found 2 to 3 times as many errors as the inexperienced testers using the same script. Okay? Now, I'm sure most of you can identify with that and understand why it's happening and what's the message here about that very prescriptive script. Okay. what's the message? What's really happening? Is it, in fact, pushing inexperienced testers to be effective, or is it channeling them into a minimally effective mode? I think you would agree that the more prescriptive you are, the less inexperienced testers would find. And the detail-oriented procedural test cases, okay, are generally aimed at less experienced testers. Now, many of you may well consider yourselves in the exploratory community. That's fine. And I suspect that some of you, in fact, signed up for this webinar because you feel that you don't have test cases. That's a pretty common perception. Okay. Well, I want to look a little bit further at exploratory testing, because there is a widely held opinion that exploratory tests are the best tests. And I'm sure that some of you, along with thinking you don't have test cases, think that the exploratory tests you're doing are the best tests. Excuse me. And one of the reasons for that is because you're probably finding a lot of defects with your exploratory tests. Now, I'm not disagreeing that exploratory tests find a lot of defects. Okay? Defects that in many instances were missed by more structured tests. But if you're using very procedural, detailed, embedded test cases, okay, you shouldn't be surprised if those tests, those procedural, detailed test cases, don't find many defects. Now, there I say illusion, okay, because the reason that it seems like you're finding so many more defects is not necessarily that exploratory testing is so good, it's that what you've been doing instead is not so good. But let's look at a couple of the issues with regard to exploratory tests. So by definition, exploratory tests are entirely based upon executing code after the code has been written. Excuse me. And the fact is that exploratory tests, by their very definition, tend to be reacting to what has been written rather than determining or revealing whether what has been written is what should have been written. And everybody that I know of who's ever looked closely at where errors originate comes to the same conclusion, that a very large percentage of errors are errors in the design, things that are wrong or misunderstood or overlooked, okay? And that when we rely only on testing what's been written, we have absolutely no ability to influence or identify errors in the design, the biggest source of errors. Okay? And frankly, when we are simply reacting to the context, we tend to fall into the shiny object syndrome. And it's very difficult to have any awareness of what we've missed, let alone that we're missing anything. So let me suggest that effective testers do use exploratory testing, but they don't use it as their primary or only test technique, that they use it as a supplement, and they supplement a more planned, more structured approach to testing. And the big change, the other big difference is that if the exploratory tests reveal something that the more structured tests did not reveal, effective testers go back and update the structured tests so that the next time they execute them, they're not relying on guesswork to find them. In other words, they are continually refining their test set based upon findings, more information, including from exploratory testing. Now, I am absolutely not an advocate of writing stuff for the sake of writing it. But we saw that writing things down can give us considerable benefits. So I would encourage you to write enough to be helpful. Don't write any more than is helpful, but don't write any less. And if the formats that you are using are not helping you, instead of simply saying, therefore don't write anything, find ways to get formats that are more effective for you. Now, hopefully this is making sense. So we'll have questions at the end, but if you want to ask any of them as we go, feel free, but I will tell you that I'm not very able to see much, and the question box spins past me pretty much. So there are 4 keys to effective testing. The first is to define correctness independently of actual results. So when we run a test, that gives us actual results. What do we compare them to? Expected results. Expected results are our way of defining correctness. In other words, if this works correctly, here's what the results should be. Now, if you have not defined your expected results, and then you run a test and get actual results, it's very likely that you will assume that whatever the actual results are what they ought to be, are the correctness. Okay? Because if you haven't defined correctness, it's easy to be misled. Okay? And in fact, you need to define correctness correctly. You need to know what the right answer is. And one of the real limiting factors of a lot of exploratory testing, especially when you get into technical business rules and complex situations, is that just because you're a tester doesn't mean that you know what the right answer is supposed to be. Okay? And I don't know about you, but I have seen people identify their tests, identify their expected results, get actual results, and never compare their actual results to their expected results. Very often they rely on things like the program blowing up. So if you multiply 4 times 3 and you get 14.77 as an answer, if it didn't blow up, it must be right. Okay? So you actually have to compare actual to expected results. Now, this other thing, following independent guidelines. Independent guidelines are things that exist for some other purpose. And if you follow relevant independent guidelines, it helps you identify things that might otherwise be overlooked. So for instance, I'm sure you've all gone to the store, to the supermarket, and if you go with a shopping list, which is an independent guideline to help you know what to buy and to make sure you've bought it, you're going to end up typically spending less money and not missing important things that if you go without a shopping list, you're going to miss. So we follow independent guidelines to help us avoid overlooking things. We identify we use the independent guidelines to help us identify whether we found what we should be finding. So let's take a simple example. We enter a customer number 123. The result comes back John P. Jones. Right or wrong? Okay. Right or wrong? Well, you don't know. You got to know what the right answer is supposed to be. Oh, it's supposed to be Jones, comma, John P. period. Now, if we don't know that it's supposed to be Jones, comma, John P. period, John P. Jones will look just fine. Okay? That's the type of thing that makes a lot of difference, because if you can't spot those differences, your testing is really not helping at all. We enter a new customer's name and address. Screen comes back with the fields cleared, ready for entering the next one, right or wrong. Oh, we got to know the expected results. It should say added. We buy 10 widgets for $14.99, right or wrong? Oh, we got to know the right answer. There's also tax on that. Now, perhaps you can see how easy it is for even experienced testers like many of you to fall into these traps. Less experienced testers are going to be even more likely to fall into these traps. So a key to effective testing is to make these 4 keys conscious. Okay? It's going to make you a better tester. It's going to make your testing more effective and also more efficient. Okay? So many of you, I'm sure, have test cases that might look like this. Your input and or condition is an operator is going to enter a customer number over here. Expected result is the system's going to look up the customer in the database and display the customer's name in that location over there. Okay? And I'm sure that many of you have test cases that are similar to this in format. If you do, just type a yes or a no into the question box. Let's see if any of you, if this looks familiar for any of you. Okay, I'm seeing yeses. Okay, now, what else do you need to perform this test? Okay, so type that into the question box if you would. What else do you need? How the data is displayed, that could be the actuals, the data. Yeah, so we need to know what the data are, what the values are. So if you are testing just from the specification in words like this at the top, then in order to carry out that test, you're going to have to interrupt your train of thought and go find data. Go find inputs, go find what their expected results are. It makes every execution an exception, and exceptions are more error prone. Okay? And it may encounter limitations on whether you're the only one who can find that data or whether you have to have somebody else involved. So another tip here is to recognize that test cases consist both of a specification in words and then the actual data values. So in this instance, customer number is the input, customer name is the expected result. Okay, and we could have many, many, many data values here. Now, notice we're keeping the data values separate from the test case specification. We're linking them logically or physically, depending upon the technology that you might be using. Okay. But the data values correspond to the specification. Okay. Now, notice this is a test case that is a low overhead test case. There's no procedure specified, okay? And the data values are good candidates for putting into a file or a table or a spreadsheet or whatever, okay? So it's going to be a relatively efficient way to capture that information, and you get the benefits of writing, so you can share it and reuse it and update it and refine it and not forget things and so forth. Another common format that people use is a script. Scripts are especially good for showing navigation, but they tend to be kind of bulky when you've got a lot of data values, such as a lot of negative tests involving the same variables. Now, this script could be considered as a bunch of simple test cases. We could view each line, each entry as a separate simple test case. Or we could view the whole thing as a more complex test case, a series of inputs and expected results. It doesn't matter, except that if one of you in your group is using it as each line as a separate test case, and somebody else is viewing it as all 6 of these lines together are a single test case, then you're getting into that area of easy misunderstandings. Okay. Once again, though, notice we've got low overhead. There's no procedure specified here. Okay. Now, a test matrix is a format that is more helpful when we want to have a lot of tests involving the same set of variables. And so each column represents a different variable, and there could be multiple expected results columns. And each row represents a separate test case. Okay. Now, the matrix format is much more economical for multiple cases involving the same variables. It's not very good for showing navigation and going from screen to screen and so forth. Okay. Now, there are a couple of other things to realize that the matrix format is often helpful for. And that is that it's very common that we will want to, in order to reduce the number of test cases that we actually have, we try to combine conditions within the same test case. So there are 2 rules about that. The first one is that for positive or valid tests, you can have any of the values for any of the fields so long as they all produce that same valid expected result. So somebody earlier mentioned boundary testing. These might be normally occurring values, each of these, or maximums or minimums or whatever. Test 2 is a negative or invalid test. There the rule is different. There you want one and only one of those variables to cause it to go negative. Because if more than one variable could cause it to go negative, we don't have any real way to know for sure which variable our test has exercised. So Once again, this is a low overhead format. There's no procedure specified. Okay? So think of what happens. Most of you use risk-based testing, sometimes consciously, sometimes unconsciously. Okay? But consider a typical way that people might use risk-based testing. They start out, they're given something to test, they create a bunch of test cases for it, they analyze and prioritize the risks that those test cases address, and then the ones that are dealing with the higher risks are the ones that they run more. Okay? Now, so let's say that you've created 100 test cases, but you only have time to run 10 of them. Well, you're going to run the 10 test cases that are dealing with the highest risk. And that's a good thing. However, what's the value of the time you spent writing those other 90 tests that you don't end up running? Not only is there no value, it's negative value because it's taken away from the time you could have spent on something more useful. Now, even if you don't write any tests, if you just come at it from a test case perspective, where do you prioritize tests for cases that you didn't think of? You're not going to include them in your priorities. And I encourage you to go back and examine how things work in your own world and get candid. Are the tests that you did think of, whether or not you wrote them, are those even the most important tests? Are those testing the most important things? There's a pretty good chance that your answers to both of those questions are going to be ones that you don't really want to hear. So some of you may be familiar with IEEE Standard 829. It's a controversial standard because a lot of people think that it's dictating writing a lot of documentation for its own sake, and those same people probably think that test cases have to be high overhead with a lot of embedded procedural detail. So I'm going to encourage you instead to use the standard as a way to organize your thinking. Thinking is our highest payback, highest leverage activity. Writing is not. So write enough to be helpful so you can remember stuff and refine it and share it and update it and so forth. Okay? And I think that you can use these thinking approaches to enhance agile and exploratory worlds without significant excess effort. Now, I'm going to look at a quick diagram of the overall structure of IEEE Standard 829. Okay? And I will tell you, I was a member of the working group that came up with the revision that was issued in 2008. I will tell you that we had two major objectives. One was to counteract this perception that the standard was mandating lots of paperwork for its own sake. I think we made some progress, but there's still lots of room there. The other was to make the standard a little bit more readable, and so I think we made more progress there, included some diagrams and so forth. The diagram on the next slide is my diagram. It's not in the standard, and the phrase on it is not in the standard. Those are both mine. But I think you'll find that if you look at the standard, that the diagram is consistent with it. So the phrase is, what must we demonstrate to be confident it works? Okay, and I'll encourage each of you to say that out loud together. 1, 2, 3, what must we demonstrate to be confident it works? Good, I could hear you all say that. Okay, we're going to ask you to say that again a couple of times. Okay, this is, in my perception the essence of what testing is about. Testing is demonstrating, not assuming, and it's demonstrating to give us confidence, not certainty that something works. So there are 4 levels of test planning and design documents. The master test plan is the project level plan for the testing project, which in turn is a sub-project within the overall development project. When we're developing the master test plan, we ask that question. Say it out loud. What must we demonstrate to be confident it works? And what we must demonstrate to be confident that the overall testing works is that there are a bunch of what are called detailed test plans. Now, these are also project plans, but for smaller sub-projects within the overall testing project. Okay? And for each of those, we ask, what must we demonstrate to be confident it works? And what we must demonstrate to be confident that a given detailed test plan works is that there is a set of features, functions, or capabilities that if they all work would cause us to say that that unit test or integration test or whatever works. For each of those features, functions, and capabilities, we can have what's called a test design specification. And for each test design specification, we ask, what must we demonstrate to be confident it works? And what we must demonstrate to be confident that a given test design specification works is that there is a set of test cases, executable inputs and/or conditions that if they all work, would give us confidence that that feature, function, or capability works. Okay? And then in addition, there are various test procedures and test reports that go along with this. Okay? Now, typical testing starts by writing test cases. Okay? We're going to see a different approach, okay? Because when we get proactive, okay, we're doing a number of important things. First of all, we're using some powerful techniques that help us spot risks that are ordinarily overlooked. So if there's a risk and you're not aware of it, you have no chance to catch it with your tests, and there's a pretty good chance that if you're not aware of it, neither is the developer. So risks that testers are not aware of tend to be more likely to be problems and are ones that testing, typical traditional testing, is highly unlikely to catch. Now, when we're proactive in our testing, we identify the risks and then create tests for those highest risks. Rather than creating a bunch of test cases and then prioritizing, we do the prioritizing of the risks first based upon a more thorough set of risks. And instead of starting with test cases, which are small risks, we start with the big risks, the large detailed test plan size risks. Because if one of those is missed, it's likely to produce showstoppers. And so we use techniques to identify more of those large risks, analyze and prioritize them. And then for the ones that are highest risk, we're going to test them more, but also earlier, because being proactive, we can identify this stuff much earlier in the development and testing process. When we're being reactive, typical testing, and especially exploratory testing, we don't have the option of being earlier, because by the time we're getting involved, things are all done. And then we drill down selectively. So for those highest risk, large detailed test plan size risks, okay, that we want to execute more, then we're going to drill down and identify more of the medium-sized test design specification risks that need to be demonstrated to give us confidence that it works. Okay? We analyze and prioritize those that are dealing with the highest risks. Those are the ones we're going to test more and earlier. The ones that are dealing with lower risks will test less, later, not at all. But we don't stop there, because we do the same thing with identifying for those highest risk test design specifications. Okay, for the medium-sized risks, what are the small risks? Okay, the test case size risks. Okay, and we've used techniques to help us identify more of them so that our prioritization is more thorough. And then the ones that are dealing with the highest risks, those are the ones we're actually going to be executing more of and earlier. The ones that are dealing with the lower risks will execute less, later, not at all. Now, by the way, the structure is helpful for organizing and managing your tests. But for any given test situation, you use the artifact or artifacts that are relevant to what you're testing. So if you're just testing a feature, function, or capability, you only need to have a test design specification and related test cases. Okay? If you only have one or two detailed test plans, you maybe don't need a master test plan. If you got a bunch of detailed test plans, the master test plan becomes very helpful for keeping track. And the structure helps us reuse both test cases, as in regression testing, but especially test designs. Okay. Now, this is a topic that is the subject of a full-day seminar that I do. It's a recorded seminar, Developing Reusable Test Designs. It's much more than we can get into now, but I'll just tell you that reusing a test design gives you a lot more leverage, a lot more efficiency than trying to reuse a bunch of related individual test cases. So test designs identify sets of test cases. They occur in a one-to-many relationship with test cases. Test procedures also act in a one-to-many relationship with test cases. Okay. So by recognizing these one-to-many relationships, okay, we can dramatically reduce redundancy. Okay. We can write a design once and reference a set of executable test cases. We can write a procedure once and reference a related set of test cases. So I know that I've gone through a lot here. Hopefully you've seen some essentials, inputs and/or conditions, and expected results. We saw the 4 keys to making them effective. You got to know the right answer, define it independent of your actual results, actually check it against the actual results, and follow independent guidelines to help you avoid overlooking things. We've seen that test cases can be written in a low overhead format, where the bulk of the writing is simply capturing inputs and/or conditions and expected results, and that by using proactive test planning and design approaches, okay, we can identify many more of the conditions that need to be tested that are so often overlooked. Okay, so hopefully that's understandable. Okay, and hopefully you found this helpful. If you want further assistance, that's what I'm and IIST are in the business of doing. We're, as we said, we've got some upcoming classes. So if you have any other questions, would you please put them into the question box? We're close to the end here. And Eric, if you want to pop in, if you can read any questions that you feel we've got time to answer, would you do that? Because I can't really catch them in the question boxes. Things been past me too much.
No, I understand, Robin, and at this time I don't have any questions in the question box.
Okay, so folks, we can work with you directly. Okay, there's a question about the costs of the boot camps, and Eric, I think you can advise people to take that offline with you. Is that right?
Correct. Yes, I will contact. Okay. Yes.
Yeah, so we have boot camps coming up in Boston, San Diego, and Minneapolis. Each one is 4 days. Okay, they qualify for the test lead certification or against other certifications. And there are also the recorded full-day seminars and the half-day seminars, making the reliable and responsible real ROI business case for test automation and truly transformational shift-left proactive testing. Okay, coming up in the next couple of months. So I want to thank everybody. If I can be of more assistance, you can reach me at Robin_Goldsmith at iist.org. Hope to see all of you in future webinars and seminars and so forth. So thank you very much, Eric. I'll let you handle it all.
Great. Thank you, Robin, for your time today. And I want to thank everyone for joining us for today's webinar sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit testinginstitute.com. Again, this webinar is one of a series of free webinars offered by IIST. Be sure to join us for the next webinar in the series, Testing in a Continuous Delivery Pipeline, Faster, Better, and Cheaper, on March 29th from 11 a.m. to 12 p.m. Central Standard Time. To learn more about this and other webinars in this series, go to testinginstitute.com. You can follow IIST on Facebook, Twitter, LinkedIn, and YouTube to find out more information about IIST news, events, and promotions. Thank you all again for joining us today, and have a great day. Thank you, Robin.
Thank you. And anybody has any questions that you didn't reach, please drop me an email at Robin_Goldsmith at iist.org, and I will endeavor to get that answer back to you.
Yes, and any other technical questions or any other questions about upcoming classes, please email onlineadmin@iist.org, and someone will get those answers to you right away. Thanks again, Robin.
Thank you.